So in this particular session, we are going to discuss about the very famous and very mostly used protocol. It's a AMBA AHB protocol. So basically, before going to start about a discussion of this AHB protocol, everything, first of all, I wanted to know, so first of all, let us categorize these protocols which we are going to use in industry. So basically, these protocols are divided into two types. One is peripheral protocols and another is on-chip protocols. So basically, anyone have any idea what do you mean by peripheral protocols? Or any names? Have you heard about any peripheral protocol names? Okay. So basically,
SPI, sir. SPI.
yeah,
Shared Peripheral
SPA.
Interface.
Okay. SPA. And any other protocol have you heard about? Okay, so basically, in the case of your peripheral protocols, you have SPA protocol or UART protocol and I2C protocol. This type of and so on. We might have other peripheral protocols also. Okay, these are the simple basic protocols which we have in the case of your peripheral protocols like SPA, UART, I2C. And in the case of your on-chip protocols, basically we have your AMBA protocols. Okay, in AMBA again we have AHB and we have APB and we also have AXI. And we also have another on-chip protocols like PCI, DDR. Okay, so these are all your on-chip protocols. Okay, so basically, what do you mean by protocol? So basically, a protocol is nothing but it's a set of rules which we need to follow for communicating between, for establishing the communication between two different modules. Okay, without any loss of data. If we want to communicate smoothly, then we are using a set of rules so that we can establish the communication. That's it. Okay. So that is why we are learning protocols. So in the case of peripheral protocols, we are basically our main concern is how to communicate with the peripheral devices like our you can say your mouse or some display or some other peripheral device which is connected via a UART interface, or you can say okay, or any other device which is connected with USB or UART connection. Okay, so we need to learn these protocols because we need to establish that particular connection, and we need to our main agenda is to transfer the data or transfer the data. Okay, and coming to this on-chip protocols, these are basically used in on our SoC system on chip. So if you have a processor and a memory which are present on a particular chip, and if you want to establish a connection, then you are going to use this on-chip protocols for communicating between these two devices. Okay, or multiple devices you can say. Okay, so that's why we are learning this particular protocols. So that is the main agenda why we are learning these protocols. Okay. So in our particular session, our main agenda is to know about what you mean by AMBA AHB protocol. Okay, so coming to this AMBA AHB protocol, the full form of your AMBA is Advanced High Performance Bus. Okay,
Hello.
so this is, yeah, anyone?
Yeah, sorry to interrupt you. If you don't mind, can you please repeat that? What is the difference between peripheral protocol and AMBA protocol?
Yeah, so basically we have two type of protocols like peripheral protocols and on-chip protocols. Okay, so in the case of peripheral protocol, like let's say suppose if you have a single chip and if you have a processor or some device, and if it wants to communicate with a peripheral device, okay, then if you want to establish this particular connection, you can use some peripheral protocols for establishing this connection between the main processor or any other device and with your peripheral device. Okay, and coming to this on-chip protocols, like let's say suppose if you have a simple SoC, and on your SoC you have some memory element, or if you say your processor, and let's say your custom RTL code, okay, which you have developed, and if you want to communicate your custom RTL developer code with your processor, okay, then and you want to communicate this two modules which are present on a single chip. So in this particular case, you are going to use your on-chip protocols. Okay, is it clear?
Yeah, sure, got it.
Yeah. So that is the main reason we are learning all this particular protocols.
Like examples.
Examples like you may have a simple 7-segment display, or you may have a simple mouse or a simple keyboard, or if let's say if you have two devices, okay, and if you have two devices connected like this, and if you want to establish this two devices connection, how we are going to establish? It will have a peripheral port and this will have a peripheral port. You can communicate this two with using this peripheral port. It's like this also you can use. Okay. Is it okay? Someone was asking, right? Is it okay? Shall we move forward? Hello, am I audible?
Yes, sir.
Okay. Yes. So coming to this AMBA AHB protocol. So AMBA stands for Advanced High Performance Bus. Okay. So this is an on-chip protocol, and you basically AMBA stands for Advanced High Performance Bus. Okay. So what do you mean by bus? Any idea? Anyone knows the full form of your bus?
It will be the communication between the IPs, I think.
Yeah. I was asking about your full form of bus. Bus. What do you mean by bus? So bus is nothing but bundle of signals. Okay. So basically, bus is nothing but it's a bundle of signals, or you can say collection of signals. Like let's say suppose if you have two IPs, okay, and if these two IPs want to communicate with each other, there may be some many set of signals which they are sharing with. Okay. So it may be some acknowledgement signals or some response signals, or it may be address signals. Okay. So all these particular lines, collection of all these particular lines are termed as your bus. Okay. So basically, why we are learning this AMBA AHB bus is nothing but this particular AMBA AHB protocol defines a set of signals. Okay. All this collection of signals are nothing but bus. So it will tell us for transferring the address, what type of signal you should use, when that particular signal should be used. And for transferring the response, what type of signal we should use, when we should provide the response, and when we should get the response, and on which line we should get the response. This will tell. And if you want to provide some address, or if you want to provide if you want to say something, okay, so it will basically say it is providing us a path for providing for establishing the communication. Okay. So that is why we are learning this, and this is nothing but your bus. Okay. So collectively all the signals are termed as your bus. Okay. So coming to this AMBA, full form is Advanced High Performance Bus, and it is a part of AMBA microcontroller bus architecture. And AHB stands for your Advanced High Performance Bus, and AMBA stands for Advanced Microcontroller Bus Architecture. So basically, it is designed to support high performance and high bandwidth communication between different components. So basically, this particular AMBA protocol supports very high performance device communication between your very high performance devices and high bandwidth communication. Like let's say suppose if we have a single SoC, and let's say if we have a high performance device like a processor, and let's say if we have some DMA controller, or some, let's say, some IP, which is a very high performance device and can access high amount of data. And if we want to establish this communication, definitely speed is one of the main concern here, because if the data increases, then speed also should be maintained properly. And it is the speed is very important, and the size of the data is also very important. So establishing this connection is very critical in this particular things. Okay. So if we have some devices like DMA controller, or some any other IP, or some, let's say suppose a processor, and these are very high performance devices and high bandwidth devices, and if we want to establish this connection, we can use this AMBA AHB protocol for establishing the connection. Okay. And there will be one more protocol also in this AMBA category. So AMBA has different protocols. One is your AHB protocol. These are all bus protocols. Okay. So one is your AHB and another is your APB. So basically this AHB deals with high performance devices and high bandwidth devices, whereas this APB deals with low performance devices like your peripherals. Okay. And which devices which have very low amount of speed, okay, which are dealing with low bandwidth. So APB is going to deal with it. And coming to there is one more type of protocol which is known as AXI. This is majorly used in industry nowadays, and AHB is not used, AXI is used. Okay.
Hello.
Yes.
Yeah, if you don't mind, may I know what are the low performance bus? I mean APB, for example.
Yeah, I will come to that particular point. I will take the example. I will tell you. Okay. In the next slides, I will show. Okay, yeah.
Sure,
And
sure.
yeah, and coming to this AXI, why we are going to learn this XI after learning AHB, we will discuss that. And yeah, so this was about your AHB and what type of devices can be used with your AHB. And basically, AHB provides a single clock edge operation. So what do you mean by single clock edge operation? That and all we are going to learn when we are discussing about your transfers. And we have AHB also supports burst transfer. So what do you mean by burst transfer? That and all specifications we are going to learn. And what do you mean by pipeline? What is this pipeline structure? How we are achieving this pipelining concept using AHB? That and all. How it is supporting it? That and all we are going to see. Now coming to this particular question, that is your APB. So what type of devices which are communicating this and all? So the same thing. Let's say suppose if we have this particular SoC, and let's say sorry, this is my processor, and let's say this wants to communicate with some IP, and let's say this IP is some I2C controller or some other controller which is controlling your peripheral. Okay, so if I want to communicate with this particular IP, basically this IP is very slow in speed, which has very slow speed. Okay, so you cannot use AHB directly for communicating with this IP, because this IP controller, it is basically a controller which is controlling your peripherals, and the speed here is very less. Okay, so in this case you cannot use your high bus protocols. You need to use your low speed protocols like your APB. Okay, so this processor, but it is a very high speed device, and your IP, this particular controller, it is a very low speed device. So in this particular case we are going to use a bridge. So we are going to use a bridge, and this processor is basically using your high speed protocol like your AHB, and your IP, which is a controller, which is using your APB. So basically, what is the role of this bridge is to convert this AHB type of signals to APB type of signals. It is taking care of this all the operations, and this APB and the commands which the processor wants to send, it will send it to the IP, and IP, it will be going to communicate with the peripheral, and it is going to control it. Okay, is it clear? Someone
Yeah,
has asked, right?
yeah. Actually, how can we decide it is low peripheral or high performance bus?
Yeah, that is what. Like, it will depend upon the specification. So for every IP, you will have one data sheet. Okay, so what is the data sheet? What is the clock frequency it is working with, and what is the data speed, and how much speed it can write the data, and how much speed it can read the data, and within one clock period, how much speed it will work. So there will be every set of specifications. Okay, so for every IP, there will be some set of specifications that we need to follow that.
Yeah, got.
Okay. Yeah. So coming back to our AMBA, so basically AMBA is nothing but advanced microcontroller bus architecture. And as I said, it is a set of specifications, okay, standardized by ARM, and it is used for communicating different functional blocks in an SoC. Okay, so AMBA consists of different protocols, like I have said. So one is your AHB, so it is for high speed, high bandwidth communication, and APB is for low power and low bandwidth peripherals. And AXI is nothing but it's an extension for your AHB. Okay, and it is for high performance and low latency and high bandwidth applications. So that AXI we will discuss later. But first, our basic concern is about AHB. Okay, so why not we are just simply starting with AXI? Why we are only starting with AHB? Because in industry all are using AXI, but why we are learning AHB? Because if your foundation is good, like if you can able to understand AHB protocol, then AXI protocol, it's a just simple extension. Okay, so if you directly start with your AXI protocol, then it will be a little bit difficult to understand the terminologies there. Okay, so but if you start a foundation for, but if you laid a foundation in this AHB, then it will be very easy task for you to understand the AXI protocol. So that's why many of the freshers or many will start with learning with this AHB protocol, and they will come to know they will get one idea. Okay, what is happening? Okay, then they will go to AXA and advanced protocols. So this is about your AHB protocol. So any doubts or any queries till now? Are we good?
Yes, clear, sir.
Yeah. Now, this AHB protocol again has different terminologies. Like you can also refer the data sheet, which is also available in the Google, so there will be AHB protocol specification that will be present. And in that particular AHB protocol specification, basically there will be some terminologies which are be written. Okay, so one terminology which we will see is your manager. And another is, I think it is written in slide also. Yeah. So one is manager and another is subordinate and third one is interconnects. Okay. So basically managers are nothing but your masters. You can say masters, and subordinates are nothing but slaves, and another is interconnect. We will come back to interconnect. First, let us try to understand what you mean by master and what you mean by slave. Okay. So if I say this as master and if I say this as slave, so are these positions final or can it be interchanged? Is my question. So if I say this particular component as master and if I say second component as slave, are these roles are fixed or they can be interchanged? Anyone, any idea? So let's say this is my component one or some IP and this is another component. Okay. Let's say I am saying this component one as master and component two as slave. Okay. So are these roles fixed or they can be interchanged? Any answers?
Fixed, sir.
Pardon?
I think fixed, I think.
Okay. So this is a main mistake we are going to do. So these roles are not fixed. Okay. So basically this can be interchanged. So you cannot say one component is master itself and another component is slave itself. It can change. Why they are going to change? Because if you see the definition of your master, master is nothing but which initiates the transactions by issuing read and write commands. If a component is issuing read and write transactions, or if a master initiates a transaction, then or if a components initiate a transaction, then it is said to be a master. Here in this particular case, this particular component is initiating the transactions, so that's why it is becoming a master. But let's say after some time, if this particular component 2 has a role of initiating the transactions, then it will be master and this component 1 will be slave. Okay, so depending upon which component is going to initiate the transaction and which component is going to respond to the transactions which was initiated by the manager, so the roles will be interchanged accordingly. Okay, but
which
what
will
we are
initiate
going,
and which will not initiate.
pardon?
So which component will initiate, which component will not initiate.
Yeah, the component which initiates is known as your master, and the component which responds to the transactions are known as your slave. So in this particular example which we are taking, this component 1 is initiating the transactions and component 2 is responding to the transactions. So that's why it is a slave.
So any examples who initiate the transaction, who receive the transaction?
Yeah, in the previous slides we have seen, right, the processor is nothing but which is initiating the transactions and the other device that is known as your slave, or some IP that is responding to the transactions like your DMA controller or some memory device or some RTL code which you have written, the IP block. Okay, that will become your slave because it is responding to the transactions. Okay.
So processor can act as a slave also.
Yes, exactly. Okay. So if you want more clarity, like if you have access to Vivado tool, so in Vivado tool, we have this IPs, AHB bus IPs. So we have master interfaces as well as slave interfaces. For your processor, there will be some set of AHB IPs will be present. So you can have both type of interfaces. You will have master interface present and slave interface present. Okay, that and all we will, if possible, we will see in the Vivado tool also. Okay, shall we move forward?
Yes, sir. If you don't mind, could you please give quick introduction about AHB? Just now, I joined.
Okay, you have joined now. Okay, so basically this AMBA AHB, it's a on-chip protocol. Why we are using? Because if we need to establish a connection between different high speed devices or high bandwidth devices, we are going to use this AMBA AHB protocol. Okay. And AMBA stands for Advanced Microcontroller Bus Architecture, and AHB stands for Advanced High Performance Bus. Okay. So this AHB protocol has some set of signals, or you can say some set of lines which we are going to discuss about. Okay, is it fine? Just now we have started. Yeah. So basically, in this particular AHB, we have some terminologies, like one is master and one is subordinate. Okay, and another is interconnect. Okay, why this interconnect is used? Because let's say if we have multiple masters, and this multiple masters want to communicate with multiple slaves. Okay, then in this particular case, we are going to use one interconnect. So this interconnect is like your arbiter, which is going to decide which master should be connected to which slave and which master should communicate with which slave. Okay, so this interconnect is going to take care of this particular communication. So if we have different masters, multiple masters and multiple slaves which want to communicate, which want to establish the connection, we are going to use, again, interconnects will be of AHB interconnect, APB interconnect, and AX interconnect. In this particular case, we are going to use AHB interconnect. Fine. Shall we move forward? So these are the three terminologies we should remember. One is manager, subordinate, and interconnect.
If I want to APB here I want to APB, what happens, sir?
Where?
Here you said that we have to use APB, AHB interconnect, right? Instead of
Yes.
I want to use APB.
Yeah, it depends upon your requirement. Like, let's say, suppose if you are establishing a connection between a high speed device and a low speed device, you are going to use APB. But there will be a bridge which should be present. Okay, so in the previous slide also I have shown you. So there will be a bridge which will be present. And the duty of this bridge is to convert your EHB signals into APB signals, and this will be given to this interconnect.
Okay.
Okay.
Yeah.
So coming to the features of your AHB, one is single clock operation and another is your burst transfers that we are going to understand with the help of your example. Okay. Just you need to remember this terminology. One is single clock edge and another is your burst transfer. Just see this particular terminology. We are going to understand this with an example in the timing diagram. So we'll try to understand. Okay. And this entire AHB protocol is a synchronous protocol because it is working with respect to your clock and it is majorly working on the rising edge of the clock. Okay. Yes. So AHB master we have seen, AHB decoder, and this and all things we have seen. Yes. So we will come back to this particular diagram. So in this particular diagram, we have a single manager and three different slaves. Okay. In this particular case, we need a decoder and multiplexer. Okay. So before discussing about all these things, first we need to understand what are the signals which are. We have some HW data, H address, HR data, H select. First, we need to understand the significance of the signals. Then only we can understand what is happening here. Okay. So first let us try to understand that particular signals and then we'll come back to this diagram at the end. Okay. So coming to the manager. So these are the signals which are associated with our manager. Okay. You can also say your master. Okay. So what is the first signal? H reset and H clock. So these are the global signals. What do you mean by global signals? Global signals means these signals are common to, yeah. Yes,
yeah, if
yes.
you don't, could you please come to previous slide?
Yes.
Yeah, here I want to know that difference between what is a manager. I think manager will be the master, right?
Yes.
Yeah, subordinate will be the slaves.
Slave.
I
Exactly.
want to know that what is the decoder and multiplexer will be acting here.
Yeah, I've told, right? So first of all, let us try to understand what are the signals and what is the signals and how these are being used. Then we can understand these rules. Okay. So first let me explain what are the signals. Then we will come back to this particular diagram and let us discuss this.
Sure,
Okay.
sir. Yeah.
So first we need to understand the role of each and every signal. Then we will come to know why we are using that particular type of circuit. Okay. So coming to the set of signals which we have for your manager are your global signals. One is your H reset and H clock. Okay, why these are global signals? Because these are which are present to your slave also. Okay, slave and every other component these are present. So that's why these are global signals. And whether it is active high or active low, can anyone tell me? H reset.
Active low, I think.
Exactly. How you're saying, so we have small and presently. Okay, so
Yeah.
it's a active low signal. Okay, what do you mean by active
Sir,
low?
I have a doubt here. Just I want to know. Just I heard about if we have small n, it will be active low.
Mm.
So how can we decide that active low or active high?
Yeah, so that's what I'm coming to. So basically, why you are saying this as active low? Because if you apply 0, if this particular signal is 0, then reset, this particular device will be in reset condition. And if you apply 1, then it will be in a non-reset condition. So basically, for your 0, it is for your 0, your reset is being active, and for your 1, reset is inactive. So that's why it is a active low signal. Okay.
Yeah, sir. Thank you.
Yeah. And coming to next set of signals, these are your transfer signals, transfer response signals. You have your H ready signal and H response signals. Okay. And these are your input to your manager. Okay. For understanding this H ready and H response, let me draw one simple diagram. So this is my manager and this is my slave. Okay. Why I'm saying this as manager? Because it is initiating the transaction. Why it is slave? Because it is responding to the transactions which was sent by our master. Okay. Now, so this H ready and H response signals are input to your manager. That means these are output to your slave. So the direction of this signal will be output to your slave, H ready. Now, as a name, okay, before that, we need to understand one more terminology. If you observe in all the signals, we have a letter H at the starting. Okay, so this H indicates it is a AHB related signal. Okay, for your APB related signals, you will have P. Okay, these are all your APB related signals. Okay. So why we are using this notation? Because when we try to convert from AHB to APB by using your bridge, then there should be no confusion, because in APB also we will have some set of signals, same set of signals we will have. So to avoid the confusion, we are using this particular notations. For AHB, we will use, for every signal, if you can observe, at the starting we will have H, and for APB protocol, for every signal we will have P. Okay. So this is just for avoiding the confusion. That's it. Yeah. So coming to the example which I was talking about, where I have a single master and a slave, and the slave is providing your H ready signal to the master. Now, what do you mean by H ready? So the name itself indicates that the slave is telling using the signal, the master, that is, it is ready for the transaction. Okay, so how the master will come to know whether the slave is ready or not? Using this particular signal, it will come to know, okay, if this particular signal is 1, then the slave is ready for the transaction. If it is 0, okay, the slave is not ready for the transaction, and the master will not disturb, or it will not send any address or data signals. Okay, by the master will sample this H ready signals, and it will come to know whether the slave is ready for the transaction or whether the slave is not ready for the transaction. Is it clear? Any doubts here? Any doubts or any queries here? Any response?
Yeah, clear, sir.
Okay. So I was asking about the response, right? So the same thing the master is also going to do. It is going to take the response from the slave. It is going to take the response from the slave. So after performing the transaction, the master is going to take the responses from the slave, whether the transaction is successfully completed or whether there is any error in the transaction or the data which the master has sent. So using this particular signal, the master will come to know whether the transaction is successfully completed or not using this H response signal. Okay. So if your H response is equal to 0, then there is an error. Then the master will come to know, okay, there was an error. And if your H response is equal to 1, then the master will come to know, okay, there is no error, successfully transaction is completed. Okay. So using
How
this,
can we find it, sir? For example, HRD is 1. How can we find it?
I didn't get you. What happened?
I mean, for example, you said that H response is 0, H response is 1.
Mm.
Radar, how can we find it?
Yeah, that is what we are going to develop in the Verilog, right? So we are going to develop the IP using this setup. These are all your protocol specifications. So the
Okay.
protocol has specified all these things. So by studying this, what we are going to do, we are going to develop our IP by following this. Okay.
Okay.
In Verilog, what we are going to do is this one. So first what we do, we study all this protocol specifications. Then if we are implementing a simple AHB IP, then we need to follow all the specifications. Okay.
If you don't mind, for example, I am saying that could you please give us the definition, like, for example, H response is 0. Give us some no, I mean definition like that, so that we can note down the notes.
Yeah. So these are all basically. First, what I'm trying to do is I'm trying to first introduce all the signals. Okay. So if you got a brief idea about all the signals, then we can go to the in detail explanation of this. Okay.
Yeah. Why? Because I'm very new to this. That's why I'm asking.
Yeah, sure. So basically, as I've said, I'm giving, right? So basically, if your H response is equal to 0, that means it is an OK response. That means, sorry, it is an error response. And if your H response is equal to 1, then it is an OK response. Okay, that means the transaction has completed successfully. So I'm asking you, like, what is the response? Have you understood or not? So like that, the master will also ask the slave whether you can able to you can able to sample the data, or is there any error? Okay, so like that, the master is basically getting the response from the slave. That's it.
Yes, got it.
Yeah. And coming to this H ready also, if your H ready is equal to 0, that means your that means your slave is busy. Okay, that means your slave is busy. And let's say if your H ready is equal to 1, the slave is ready for the transaction. The slave is ready for the transaction. Okay. And if you see the direction also, H ready and H response are input to your manager. Is it clear?
Yes, sir. These are from the master side to output, right?
These are from slave to master. The arrow direction you can see. So these are inwards to your master.
Okay, got. Yeah.
Okay. Yeah. And coming to another signal, which is known as HR data signal. Okay. So what do you mean by HR data signal? HR data is nothing but, okay. So before going to see about this HR data, let us see about this H right. Okay. So this all signals, this category is nothing but address and control signals. So for this, let me take one example. It will be more clear. So this is my master and this is my slave. Now, so if I want to perform a write operation, then the direction of the data will be from master to slave. If it is a write operation, then the direction of the data will be from master to slave. So this is a write operation. And if I want to perform a read operation, then the direction of data will be from slave to master. This direction we need to be very careful. This is nothing but my data direction I was talking about. Okay. So if it is a write operation, then the data direction will be from master to slave. And if it is a read operation, then the data direction will be from slave to master. This we need to be careful. Okay. Now, how to decide whether we are performing write operation or whether we are performing read operation? So that particular operation is taken care by your H write signal. And if you see, the direction of this signal is your output to the master. Okay. So if I have a master like this, and if I have a slave like this, and this H write signal is output to your master. Now, let's say if the master wants to perform a write operation, then this H write signal value will be equal to 1. That means it is a write operation. And let's say if the master wants to perform a read operation, then this H write value will be equal to 0. Then it is a read operation. Now, this is input to your slave. So the slave will sample this particular signal H write, and by seeing this H write signal, okay, if H write is equal to 1, then the slave will come to know that master is trying to write some data to it. Okay, and it will accept accordingly. And if the slave will come to know that H write is equal to 0, then it will come to know that, okay, the master wants to read the data from me, and it will provide the data accordingly. Is it clear? H write signal, is it clear?
Yes, sir.
Any doubts in this H write signal?
Hello, sir. Master wants to read or the slave wants to read?
Master wants to read. That's what I would drawn, right? Amark, master wants to read the data from the slave.
Okay, sir.
Okay. So master, if it wants to read the data, the arrow mark. So you can follow the arrow mark direction. It is reading the data from the slave. And if master wants to write the data into the slave, the arrow mark direction is this. Okay. How the write operation or read operation is taken care? It is taken care by this signal, which is known as your H write signal. If your H write is equal to 1, then it is a write operation. That is, master is writing the data into the slave. And if your H write is equal to 0, that is a read operation. That means master is reading the data from the slave. Got it? Any doubts in this?
Clear, sir.
Okay. Okay. Yes. Now, let's say our H write is equal to 0. Let's say if our H write is equal to 0, then what is this operation? It is a read operation. Then our master wants to read the data from our slave. Okay. And what is the direction of data? It is from slave to master.
Slave to master.
Exactly. So that means H write is equal to 0. Now, okay, a master wants to read the data, but how, which signal it is going to using, which signal it is going to use for reading the data? So it is going to use,
equal to 1, I think.
Pardon?
H rate would be high.
No. Master wants to read the data. H write is equal to 0. And from which signal it will get the data? On which bus it is, the slave is going to send the data. So that particular signal is nothing but our HR data. Okay. So using this particular signal, the slave will send the data to our master. We need to perform read operation. Okay, well and good. But how the slave is going to send the data, using which signal it is going to send? It is going to use this signal and it is going to send the data using this particular signal. The data will be sent over this particular signal. Okay.
Yeah.
Okay. Now, what is the width of your signal? This particular signal, the width of this signal is 32-bit. Okay. So it is a 32-bit bus. So using this bus, the slave is going to send the data to our master. Okay. Once again, I will repeat this particular point. If I want to perform a read operation, that means H write is equal to 0. Okay. First, what is the master is doing? This is your output to your master. Okay. First of all, what is your master is doing? It is providing your H write is equal to 0. So the slave will come to know, okay, the master wants to read the data. Now, on which signal the slave will send the data? Using this HR data signal, or you can say it is a bus because it is a 32-bit, right? So the width is 32-bit. So using this particular bus, it is going to send the data over this particular bus to the master. So the master will receive the data on this particular bus if it is a read operation. Is it clear? Any doubts or any queries in this? Okay, I hope there is. Okay, next. So what is our next? Let's say our H write is equal to 1. Can anyone tell me whether it is write operation or read operation?
Right operation.
Exactly, write operation. Now what is the direction of data? What is the direction? Exactly, master to slave. Now, if it is a read operation, we are getting the data using this HR data bus. And if it is a write operation, then the master needs to send the data to the slave. Okay. On which bus it is going to send? It is going to use this bus. What is this bus known as? HW data. Okay. HW data. So using this bus, the master is going to send the write data to the slave. So I will draw here. So using this bus, HW data, the master it is going to send the data items to the slave. And let's say if the master wants to read the data, then which bus it is going to use? It is going to use HR data. In the name itself, you can find out if it is a write operation, W we have, and if it is a read operation, R we have. So this is how writing and reading are happening from the master to slave. Is it clear?
Yes, sir.
Yes. Now, so these are your data signals. if you want to write the data or if you want to read the data, you are going to use the signals. Okay. And in Verilog also, if you are developing this particular IP, you are going to take care of, you are going to declare all the signals. And if you want to write the data, you are going to use this particular signal in Verilog coding also. Okay. Now let me erase all this. Yes. Now coming to one more signal, that is your H address. HADDR. ADDR stands for your address. And the width of this particular signal is also 32 bits. It is also 32 bits. Now, can anyone tell me why do we need this signal? H address? Any idea, anyone? Why do we need address?
To send the data, we need to know which slave we have to send, I think.
Exactly, correct. Okay. Let's say suppose if we have three different slaves. Okay, slave 1, slave 2, slave 3. So every slave will have a set of addresses. One starting address it will have and one ending address we have. Okay. So let's say this ending address is FF. So like this, it will have some starting address and we have some end address, and we have some starting address and we have some end address. So this starting address, the master should come to know, okay, so this is your slave address and this is your slave address. Okay. So for knowing that particular address, okay, so previously we have one diagram, right? So for this particular diagram, we need this particular address. Okay. We will come back to that diagram. What is it? Okay. So using this H address signal, it is given to your decoder logic. This is given to your decoder logic. This decoder is going to decode your what is the address and which and this address is corresponding to which particular slave it is going to decide, and accordingly it is going to establish the connection with that particular slave. Okay. So the master, what it is going to do, it is going to give the address to the decoder, because if you see in the diagram also, it is output to your master. So master, it is going to give the address to the decoder. The decoder will decode the address of which slave it is. Okay. Decoder knows the address is this particular slave, or it is belonging to slave 2 or it is belonging to slave 3. So accordingly, it will decode the address and it is going to provide it is going to establish the connection between that particular master and with respective slave. Is it clear? Any doubts or any queries in this? Is it clear?
Yes, sir.
Yes. And there is one more role for this address that we will discuss when we are discussing about transfer types. So basically your H address will have two roles. One is for obviously selecting your slave. Okay. One is for selecting the slave. And there will be one more role, which is a very, very important role. Okay. Selecting the slave. This is one role we have. And there will be one more important role for this H address that we will discuss when we are discussing about the timing. There I will explain. Okay. Next, so this was about your H address and your H write signal. Now, what is this H size? Let us try to understand what is your H size. So we will take one simple master and slave, and let's say if it is a write operation, that means the data is written from master to slave. Now, let's say if we are sending one packet or one data item, let's say. Now, what is the width of this packet is decided by your H size. Whether the packet width is 1 byte, so the size will start from 1 byte in this protocol. The least size is 1 byte, okay, or whether it is 2 byte, or whether it is 4 byte, okay, or whether it is 8 byte. So this width of the packet is decided by H size signal. And if you can see here, H size is 2 down to 0. That means 3 bits. Okay. So this H size signal is 3 bits. For 3 bits, how many combinations will be there? Can anyone tell me? Using 3 bits, how much? What is the range of numbers you can represent?
0 to 7.
Exactly, 0 to 7. Now let's say this H size is equal to 0, 0, 0. That means the size is nothing but 1 byte. And let's say if your H size is nothing but 0, 0, 1, it is 2 byte. And if your H size is equal to 0, 1, 0, it is 4 byte. So like this, the protocol is specifying the values of your H sizes. And we have a table in the slides also. I will show you one. Yeah, this one. So if your head size is equal to 000, then it is a size of the packet is 8 bits and it is a byte. And if it is 001, it is 16. That is half word. And 010 word, that means 30 bits, or you can say 4 bytes. So like this, depending upon the values of your head size, okay, depending upon the values of your head size, we are going to decide the width of your packet. Okay, this is how we are going to define the width of the packet, and the slave will come to know, okay, what is the size of packet which the master is sending. So using this particular signal, the slave will come to know. Is it clear? Any doubts or any queries in this? All good? All clear? Shall we move forward? Okay, I hope everything is clear. Now, next is your H burst. Okay, let us try to understand what is this H burst. Like, let's say suppose if we have a single master and a slave. Okay, now let's say if this particular master is sending, if it is performing a write operation. Okay, if it is performing a write operation, and during this write operation can be of 4 clock cycles or 5 clock cycles that we will discuss. So if it is performing a write operation, okay, and in this particular transfer, this master can send 4 packets of data, or it can send 8 packets of data, or it can send 16 packets of data, so on. In a single transaction, I'm talking about in a single transaction. In a single transaction, it may be a write transaction or read transaction. A master can write 8 packets of data, or it can write 16 packets of data, or it can send 14 packets of data in a single transaction. Or it can read 8 packets of data, 16 packets of data, and you can say 4 packets of data in a single go. Okay. So how the number of packets is decided, like let's say suppose if you have 4 packets of data, if you want to write 4 packets of data, how this is being decided? This is nothing but it is decided by this burst. Burst is nothing but it's a flow of data in a single go. Okay, in a single go, how many packets of data you're going to send? It is decided by your burst. And the width of this burst signal is also of 3 bits. Now 3 bits, how many numbers you can represent? Again, 0 to 7 you can represent. And this H burst signal has each and every value. For each and every value, we have one specific behavior. If it is 000, it is an single burst, single transfer. That is, you're only going to send only 1 packet of data in a single transaction. And if your H burst is equal to 001, it is a undefined length burst. So what is this undefined length burst? Everything we are going to discuss. And if it is 010, it is wrap4. So don't worry about this term. Just see the beat. This is nothing but your beat. Beat is nothing but number of packets you are going to send in a single transaction. Here 4 indicates you are going to send 4 packets of data. And we have wrap 8, INCR 8, and what is this wrap and what is this INCR? So don't worry about this terminologies. Just focus upon the number of beats you are having. Is this clear? Any doubts or any queries in this? Shall we move forward?
Yes, sir.
Yes. So let's say I will take one example. So this is our master and this is our slave. Okay. Now, if I want to perform a write operation, then what is the signal? What is the value of H write? Can anyone tell me if I want to perform a write operation?
1.
Well, 1. And if I want to send 4 packets of data, okay, in a single transaction, I want to send 4 packets of data. I'm using INCR4. Okay, don't worry about this INCR4. Just see the number of packets what I'm sending. Okay, so this INCR wrap4 we'll discuss later. So I'm sending 4 packets of data like this, and let's say my head size is equal to 0. What is this head size indicating? Can anyone tell me? It is indicating the
Each of
width
the
of,
packet.
yeah, exactly, width of your each and every packet. It is nothing but 1 byte. Now, can anyone tell me, during this write transaction, how many bytes of data have we sent? Can anyone say, can anyone please answer? How many bytes of data have we sent during this particular transaction?
8 byte.
So basically, any other answers? This is 1 byte. This is 1 byte. This is 1 byte. And this is 1 byte. Okay. And we are ending the transaction because it is a INCF. So total 4 bytes of data we are sending in this transaction. Is it clear for everyone? Any doubts or any queries in this?
Yeah, no, sir.
Exactly. So this is how we are going to calculate what is the width of entire data which we are going to send in a transaction. Okay. And this all rules will be applicable for your read operation also. Just the data direction will be reversed from slave to master. That's it. Okay. Yeah. Next is HP dot. This is an optional signal. If you want to use, you can use, or else you can leave the signal. And next we are going to discuss, and this HMAS lock is also an optional signal. So these are your advanced features. And generally we are not going to use this particular features. Okay. After discussing all the basic signals, then we can explore this HP dot and HMAS lock. Okay. First we need to understand the basic functionality. Without understanding the basic functionality, we cannot go into advanced things. Okay. Next is trans, H trans. It is also output to your master. Okay. So your H trans stand for transfer type. It is nothing but transfer. So it is of 2 bits width. 2 bits mean we have 4 number of combinations 0, 0, 0, 1, 1, 0, 1, 1. Okay. So basically this is output to your master. If you see the direction is very important in this particular case. Okay. So if you see, this is output to your master, this particular signal. Now, if it is 0, 0, that means it is an idle. 0, 1, it means it is busy. And 1, 0, it means non-sequential. And 1, 1, it is nothing but sequential. Non-sequential, sequential, after learning the transfer types only, we will come to know what is this non-sequential and non-sequential. So we can discuss this particular signals in the upcoming slides after discussing about this transfer types. Okay, so after discussing at least one write example and one read example only, we can understand what you mean by this non-sequential and sequential. So I cannot discuss it in the basics. Okay. So what we need to understand now is this 2 signals. That is your 0, 0 and 0, 1. That is idle and busy. Idle means master is nothing, not involved in any transaction. Busy means master is involved in some transaction. Okay. So that is nothing but your H trans. Is it clear? Shall we move forward? Yes. So coming back to the first example which we have seen here. So let us try to understand what is this particular example which we have here. So we have a single master and 3 subordinates, subordinate 1, subordinate 2, subordinate 3. Okay. Now, let's say if my master wants to communicate with the subordinate 1. Okay. How it is going to communicate with the subordinate 1? It is first of all going to give the address of that particular subordinate. Okay. And it is going to give it to the decoder. The decoder, what is going to do? It is going to decode the address which the master has sent, and it will come to know which particular slave it wants to communicate. Accordingly, it will make this particular selection line to high. Okay. So let's say the manager wants to communicate with subordinate 1. What it will do? It will provide the particular address corresponding to subordinate 1. The subordinate 1 address will be decoded here, and it is going to activate the corresponding line. So we are going to establish the connection between this manager and subordinate 1. Like let's say suppose if this manager wants to communicate with subordinate 2, what it is going to do? The manager, it is going to provide the corresponding address of subordinate to the decoder. Decoder, it will decode the address, and it is going to activate this selection line. So the subordinate 2 will be activated and rest all subordinates will be deactivated. And there will be a connection link established between this manager and subordinate. So like this, we are using this decoder for decoding the address which has been sent by the master, and we are going to establish the connection. Now, after that, if the manager wants to read the data, okay, subordinate 1 is sending one set of data, subordinate 2 is sending one set of data, subordinate 3 is sending one set of data. Okay, so if we want to, so the manager from which subordinate it should receive the data, that is also decoded by this address. So let's say if the manager wants to read the data from subordinate 1, if the manager wants to read the data from subordinate 1, what it is going to do, it is going to provide the subsequent address which is related to the subordinate. Okay, so this particular select line will be activated, and here also if you see from the decoder we are having the multiplexer select input. Okay, so accordingly the address which was selected by the master, so the corresponding slave will be selected, so the corresponding select line will be activated, and this particular input will be given to the output. I hope you already know about what do you mean by decoder and what do you mean by multiplexer. Yeah, is it clear?
Yeah, yeah, sir.
Yeah. So any doubts or any queries till now? Are we good? So we will end our discussion here. So if possible, we will discuss the later things. I think the meet is for 1 hour. So this is just your introduction about your signals and what are the signals and what is the use of each and every signal. This is very important to understand because these signals are going to play a key role for understanding the transfers. Okay. Yes. So that's about this particular session. If you have any doubts, we can discuss about things, or else I will end this session. Okay. Thank you.